Hi dear students, welcome to my channel. This is the continuation of the fundamentals of the physics. Today what we discuss, buoyancy force. How this buoyancy force we can calculate, where it comes actually. You know, most of the people like swimming. You know, we swim in swimming pool, in water, in pond, in a river, sometimes in ocean, sea also. Then why we like swimming? What happens when you just jump into the water? When you are just standing on the floor and you are walking, I am standing here, my weight equal to my mass into acceleration due to gravity, m into g. If I jump into the water, now I am swimming, I feel some weight loss is there in my body. That is why we feel happy to swim, because our weight is decreased. Then how much weight is decreased? That part we will discuss today class. That is due to the buoyancy force. In the previous class we discussed, if you are going inside the water, the pressure due to the water or any liquid increases. The pressure P equal to rho into G into H. Already we derived that. H is the depth of the water or any liquid. As H is increasing, as you are going deep inside the water, the pressure increases. Based on this concept, we will calculate the buoyancy force and Archimedes principle also. Okay. Now I will give one example. Take a container and take one object and fill the container with any liquid. Take it water. Now you drop that object in the water. Suppose that object is sink. It has gone inside the liquid. There will be some weight loss will be there. The weight loss by the object in the fluid is equal to the weight of the liquid displaced by the object. That weight loss is equal to buoyancy force. This definition looks simple, bolne mein, when I am telling, but you may get confused. I will give one beautiful example, you will understand very clearly. Okay, the buoyancy force is equal to weight lost by the object in the fluid. Okay, that weight lost equal to, I told no, the weight of the liquid displaced. What does it mean? I am taking a container, it has marking, suppose up to here I filled with water. Suppose this is from here to here, some 2 liter, here 2 liter marking is there. Now I will drop one object inside the liquid. This is one object. I will drop this into the liquid. This object gone inside. Now it is at the bottom of the container. Okay, I dropped this like this. Because of this, it is completely immersed in the liquid. The level will increase. Agree? How much increases? Initial level is here. This is initial level. Because of this object gone inside the fluid, the liquid displaced by the object is equal to the liquid level raised. Suppose level raised up to here, this much level raised. Suppose it is some 2.5 liter. From this marking is 2.5 liter. So this is 2 liter, this is 2.5 liter. So how much level difference? 2.5 liter from here to here, 2.5 liter minus 2 liter. So 0.5 liter volume of fluid displaced by the object. You know the volume, you know the density of the fluid, you can find out what is the mass of this fluid. Mass of the fluid or liquid ml is equal to this volume into density of the fluid. So this mass of the fluid into G. This is weight loss, WL I am calling. This is the weight loss by the object. So you can write WL is equal to ML is equal to this rho into V, the volume displaced, into G. So rho is density of the fluid, V is the volume displaced by the object, into G. This is called buoyancy force, BUOYANCY, buoyancy force. This buoyancy force direction is opposite to the gravitational force. So that is why when this object is outside, the weight of the object is, suppose this mass is m into G downward when it is in the air. Once you drop this object inside the fluid, it feel weight loss is there. Just like we are swimming in the water, no? We feel weight loss because of buoyancy force. So the buoyancy force is equal to the weight of the liquid displaced by the object. That is rho into V into G. Rho is the density of the fluid, V is the volume displaced by the object, into G. This is the buoyancy force. I think you understand it very clearly. I will give some more examples and problems related to buoyancy force. You will understand very clearly. Okay? Now we will understand what is the origin of this buoyancy force. Okay? Same container, it's filled with water. Suppose this object is floating somewhere inside. Suppose object is here. Okay? The pressure inside the fluid or liquid, suppose at this point the depth is from the top h1. At this point the depth is from here to here, this is h2. Okay? The pressure at this point I am calling P1. Pressure at this point I am calling P2. Okay? So P1 is equal to rho into G into H1. P2 is equal to rho into G into H2. Which is higher? H1 is greater than H2. So P1 is greater than P2. Okay? Now the relation between pressure and force. Force F1 is equal to pressure P1 into area. Here force F2 is equal to pressure P2 into area. Suppose for this surface, the force direction here at this point, due to pressure of the fluid P1, the force is upward. This is F1 force. Okay. So here the pressure due to the fluid and force will be downward, that is F2. Because of the fluid, the pressure P1 and P2 both are different. P1 is greater than P2, then F1 is greater than F2. So upward force F1 is greater than downward force F2. This difference in force F1 minus F2 is equal to FB. That is by FB matlab buoyancy force. Buoyancy force. Okay. Now you can substitute. F1 is equal to how much? P1 into A. P1 into A. A is area. Area of the bottom of the object is same as area of the top of the object. So P1 minus P2 into area. What is P1? Rho G H1. Rho G H1 minus rho G H2. Okay, into area. Okay. Now rho G you can take common out. Then what you will get here? Here I will write buoyancy force FB equal to rho G is common. Here A into H1. A into H1 minus A into H2. A into H1 is nothing but this area into H1 from here to here. So you are taking a column from up, suppose from here to here, H1 into area. So volume of this much column, that is V1 I am calling. Matlab from here to here volume minus A into H2 volume of this part, that is V2. So volume of this complete portion minus volume of this portion. What you will get? The volume of this object you will get. Rho G into V1 minus V2. So rho G into V. In the previous also we derived same thing. Rho is the density of the fluid, G is the acceleration due to gravity, V is the volume of the liquid displaced. The volume of the liquid displaced is same as volume of the object. So this is the origin of buoyancy force. Because of there is difference in pressure at different points inside the fluid, that is why this buoyancy force come into the picture. So that is why we feel weightless. So completely weight is zero, not like that. Your weight will be decreased. Okay, I hope you understood this.